Hello everyone, hope you are doing great. Today we are diving into something really cool, that is how to sync your 3D scene with the HTML using reactive fiber. Now, I know, learning 3D on web is very tough. Like there is barely any structured resources out there. It's tough to find exactly how things work behind the scenes, especially when it comes to syncing your UI with 3D elements. But don't worry, in this video we are going to break it down all together. So, first we'll go through some theory that is important. Boring, not that boring, but I'll try to keep it entertaining. But then, don't worry. But then we'll put that knowledge into practice by creating this animation. This animation, as you can see right on screen. And hey, if you truly appreciate this kind of tutorials, please consider subscribing to this channel. It really helps me and motivates me to create some content like this. So, by the way, if you are new here, welcome. My name is Govind. I'm a creative developer based in India, and I create this kind of websites. And if you are looking for someone to help build your build something like this, then I'm here to help. All right, let's not waste more time. Let's go right into it. Let's start. So before starting, I want to show you guys something. So if we come on awards, I'm going to show you some examples of website that uses this kind of technique. So if we come to explore biotechnology and then come to three, there is a separate section for it, 3D website and WebGL sites. If you come over here, you can see a lot of website uses this thing. If I open it and you can see this thing, this DNA structure that is in 3D, it interacts with me, the scroll. I'm scrolling and it it also translates with the scroll. So I'm talking about that. And if we come to that second one, this one is built on Peachworlds, a no-code platform, but it also has that same thing. You can see that 3D is interacting with the scroll. Yeah, in this example as well. So I'm talking about that thing. So now let's jump into the tutorial. We'll start from scratch. Inside of community, let's create 3D with scroll. Let's open it with our code editor. So we have to create a React app. So let's use Vite for that. npm create Vite latest dot. So yeah, and vanilla, no, not vanilla, React and JavaScript. npm install. Now we have to install some other packages for that, for it to work. So npm install 3 and 3 for 3js, then React 3 fiber, then React 3 Dre, and yeah, that's all. And another special package that will help us to sync our canvas with scroll. So let's just clean up something. So we are going to use another package, that is scroll rig 14. It's R3F scroll rig by 14 islands, and we have to install it. So npm install @14 islands slash R3F dash scroll dash rig. So you can see this is the command to install it. npm I 14 island slash R3F slash R3F scroll rig, and enter, and it will install that package. And I'll tell you everything about like how can we use this package to sync our HTML. So let's just run the server for now. Inside of src, let's create another component folder. Components, create global scene jsx. Why global? I'll tell you in a minute. Let's use this fragment and global scene. Yeah, So inside of global scene, we have to use two things. First of all, it's not suggesting some imports, auto suggesting. So for that, we have to create a file js config.json. Just pass an empty object here. Okay, so it's global canvas by R3F scroll rig, and it's like the usual canvas that React 3 fiber provides us. Another thing we have to import, and that is smooth scroll bar, and it uses Linux back of the hood. And why this is important, like I can explain all of this if you guys want. So you guys can tell me in comments, should I create another version of it, another version of this tutorial, how everything works back of the hood in vanilla JS, so I can explain you guys. So let me know in the comments, should I create that tutorial for you guys. So create another component, demo JSX. So RAFCE, and it's a div. So I'm just going to use tailwind, so don't worry, going to add the tailwind cdn here. It's not recommended obviously, but we can't waste much time on it. I don't want to waste much time on it, so let's just create tailwind, adds tailwind cdn here, and tailwind.js to get suggestions. So it's height screen with full, and let's just create another div. Okay, let's give it a background color of bg slate 900. Let's just add this demo. Yeah, so now let's just make a red div, size 52, and bg red 500. So you can see that red box here. I'm going to make it absolute and place it in random place. So absolute top to 1 to left to 1 by 3. Yeah, that will work for now. 1 by 4 I guess would be better. Yeah, that will work. So it is a 3D. It's not 3D, it's a div. So we are going to place a 3D cube in the place of that. And believe me, it will also interact with the scroll. So let's make height 200 viewport height, and we can get some area to scroll. Yeah, it will also interact with the scroll. So here is the trick. How we are going to do the thing is, we can create a component here, function canvas. We can add our 3D scene and models and everything. So it will return use canvas by R3 scroll rig, and inside that we have to add scroll scene, and inside it we can add anything we want, like our mesh and everything we want. But before that, this scroll scene requires one thing, and that is track. We have to pass it one element that it can track. So let's just reference this div. So const track, and use ref null. Let's just pass null default, reference it, so track, and we're going to add that canvas here. Canvas, this will render this canvas component here. Let me just remove this div from here, and we can add it here, but we have to wrap everything in a fragment right now, otherwise it will give us some error. So we can just cut this thing and paste it right here. So here is the thing, it's a div, and it has, we are rendering a canvas component here. Canvas component has a div which we are referencing it use on this variable, and we will pass it to track. We'll tell the scroll scene to track it. And now inside of scroll scene we have to pass a function callback, and this callback will return return a mesh. Let's use um, box geometry and mesh normal material for now, just for the sake of the thing. And this, in this callback function, we get something called props. If I log it, it has some variables in it. So it has track and everything. It has very important property, that is scale, and it will determine how much scale should it be. So we can destructure it right here, props, and you will see a cube appeared here. Suddenly a cube appeared here. So if I come to global scene, and inside of global canvas, if I add orbit controls inside it, so you can now scroll and drag it. Now you can see this. Can you see this box over this div? It's a 3D element over that has exact same position of this div. So it looks like they are just overlapping each other. So let's just comment this thing, orbit controls, and if I just scroll now, you can see this div is scrolling with it. And if I now just remove this prop and let's pass scale here, so 5, sorry, 50, yeah, you can see a cube here. And can you see that we can see the bottom part of it, top part of it with the scroll, and this is the magic of it. So it's all about the theory. It's all everything we need to know about theory. And now we are going to learn another thing, that is how can we sync our image, and that will eventually help us to create that demo we saw earlier. So let's create another component, name it page JSX FCE C, and I'm just going to comment this demo in app.jsx and add page instead of this. So um, let me just style it a bit. So class name minimum height screen with full, and bg slate 900. And yeah, I'm going to just download some images from Unsplash, and then we can use those images to create that grid effect. Okay, so I just downloaded these 4 images from Unsplash and put it inside of public. And okay, so let's add those images here. Image 1.png, 2.png, 3.png, 4.png. Yeah, and let's make it width. Let's take width 50 viewport width. Yeah, and it can take height of it. So let's add some padding. Let's make it flex column, gap y, 5 viewport height, py 5 viewport height, and let's center everything by just saying justify content center. Sorry, align item center, align items center. Okay, so it's just basic css to add some images in the center. So now we are going to replace these images with the actual uh, 3D image. So let's just create another component inside of components. So name it image JSX RAFCE, and let's pass this empty fragments and inside of it. So let's render that image component. Yeah, so it will, we have to pass it class name first of all. Let's just copy this thing, class name and src, just paste it, and you can see we are getting props here. If I log it now, props. You'll see these two things, class name and src. So we have to, first of all, this step is very crucial, very important. Just see what I'm doing here. So let's just create an image, and it will take that exact src, props.src, and let's just keep the alt tag for now, and let's just parse class name equals class name. Sorry, class, not class name exactly. We can destructure it right here. So class name and src, and then dot 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 props. The rest of all will save into this props. So let's pass src here, class name here, and you can see there is another image. It's HTML image. So let's just create. Did you remember those steps? We have to use canvas by R3F scroll rig. Inside of it, we have to add a scroll scene. Just do it with me. So, and it needs to track something. So we have to reference the image. So const image. So use ref null, and let's pass the ref image, and it will need the image here. It will need to track that image here. So you can see that red div has appeared here. So we can pass it an object and then a callback, and it will return a mesh plane geometry, obviously, because that's a plane, and mesh basic material. And we are getting props here, so props, and we have to destructure it right here. Dot 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 props. Yeah. So it's a mesh basic material will take over it. And now inside of mesh basic material, let's just map. Oh, wait. Now we have to map the texture of it. So we have to create the texture of it. Let's just create another component because we have to handle that bending and everything inside it. So let's create WebGL image JSX RFC, and let's just uh, cut everything inside of return and render WebGL image. Yeah, okay, and let's just paste that we copied earlier, and it needs to accept that dot 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 props here, props. Yeah, so we can see a red box, can't we see? We can't see a box here. Why? Okay, we need to pass props here, dot 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 props. Yeah, if I refresh, you can see a gray box has appeared over everything. So now we also have to pass this track element so that we can get that src, or we have to pass the src from it. So src, and it's the src. Okay, src, and we have to get the src here before props. So src, and put comma here. So if I console the src, you can see it 1.png. So we have to make it texture, convert this to texture. So const texture equals use texture by Dre, R3F Dre, and src. Put the src right here. So now just map the texture here. So you can see it's a WebGL image. The color is a bit different. And why is that? So to fix that, by default it has some color corrections applied. So to come here in global scene and in global canvas, let's just pass flat here. So it will add that. If I just remove that, you can see a difference. Refresh, you can see a bit difference. If I add flat, you can see the difference. So yeah, The color correction is disabled now. So for that bending effect, we have to use our custom shader material. So for that, let's just remove everything and shader material. And it needs two things. First of all, vertex shader, then fragment shader, and then uniforms. Uniforms are those, let's pass the texture here. U texture and value texture. If you don't know what I'm doing here, so you should check out previous tutorials. You can see get the links in top right corner. What I did is I just add that shader material and passed it vertex shader, fragment shader, and pass the texture through the uniform. And inside of vertex you can see just basic boilerplate and passing the varying and then showing the texture in the fragment shader. So if it looks new to you, then you should probably check out this tutorial. You can get the link in top right corner. So yeah, now let's add that bending effect. So come to this vertex shader. Now we have to modify this position parameter. So now let's create a copy of it. So vector 3 new position equals position, and let's use new position instead of position, directly position. Okay, so new position dot x plus equals, if I do 0.5, you can see it has shifted to the right, but you can see another image at the bottom of it. What's that? It's the HTML element, so we have to hide it first. So let's come to image, and inside of class name let's pass invisible sorry invisible invisible plus and space. Yeah, so it will hide that image. You can't see that image. And what this class does is it adds visibility hidden. So if you are using plain css or any other library, so you can give it visibility hidden to hide it. Okay, so now come to vertex. So it's reacting to it. So now we have to bend it in y axis. So let's y, make it y, and we can use uv dot x. We can use the coordinates of x axis to bend it in y axis. So refresh it. You can see this has bent like this. So in this demo I showed you earlier, it's bending in from center. So to bend, it's like some sine wave. So if you don't know what sine wave is, sorry, sine wave spelling is wrong. Sine wave. So yeah, if you don't know what sine wave is, it's a just it takes an angle and gives us this output like this. It varies like this. So we can use that sine wave to bend it like this. So use that sine wave, sine, and this uv dot x varies from 0 to 1. So it's 0 here and 1 here, right here in top sorry, bottom right. So it takes 0 to 1 to bend to complete the whole cycle. So here we need this cycle. It's 0 here and pi here, pi angle here. So pi is 3.14, yeah, 1. So it's pi here. So we have to multiply it with pi. Uh, we have to multiply it with the pi. Why? Because at pi angle it completes one cycle. So pi value is 3.141. So if I refresh now, it's not bending. Why is that happening? So it doesn't have enough subdivisions to do that. What I'm saying. So if I come here in WebGL image and pass wireframe, you can see it has only one subdivision. So we have to increase it. So how can we do that? So come to plane geometry and pass it arcs. It takes an array, and first value is the width. So 1 unit, second one is height, so height is 1 unit, and third one is subdivision across x-axis. So let's pass 32, and across y it's also 32. So you can see this has now enough subdivisions. So I'm going to disable the wireframe for now. It's just too much. So we can decrease that by multiplying with smaller values. So 0.1. It's you can see it has less bending now. So now in this demo, you can see this bending depends on the scroll velocity of the user. So here we can do so by using another using one hook that's um, provided by the what we say provided by the R3F scroll rig. So what's that? It's const. Let's us it's we can get that lennis variable here. So const lennis global lennis, sorry, global lennis, name it global lennis, and use scroll bar. It's the hook. The hook is named use scroll bar. So if I use effect, use effect, if I come here and pass it as a sorry, if I come here and let's make uh, console it global lennis, you can see, yeah, this one. You can see it has another lennis variable inside it. So it's the lennis, exact lennis that we are finding. So let's create here variable const lennis equals global lennis dot dash dash lennis underscore lennis. So it's the lennis we are finding. So if you are familiar with lennis, you know another method that lennis provides, that's lennis dot on method, and it takes scroll first of all, and then it will return another callback, and in this callback we can get the velocity. So if I log the velocity now, you can see, yeah, you can see the velocity is changing with the scroll. If I stop the scrolling, you can see it's 0 right now. If I scroll to top, then you can see the scroll velocity is increasing gradually and then decreasing gradually. If I go to top, it goes to minus and then gradually decreases to 0. So it's the velocity of it. So we have to pass it through the uniform. So to pass that, I'm going to cut this uniform object from here and create another variable outside of it. So const uniforms, and let's pass uniform here. So we can pass u velocity as the let's pass value 0, and depending on this velocity I will multiply this velocity right here, so it will affect that bending effect. So here let's just update the velocity uniform u velocity dot value and update it, make it velocity equals to velocity. So if I refresh now and go to vertex shader, let's access that uniform. It's a float variable u velocity, sorry, and I have to multiply it right here. So u velocity. So if I refresh now, if I scroll, you can see this bending is just too much. So I have to just multiply it with a small number. So 0.1 maybe. Yeah, is still too much. So let's multiply with 0.001. It's still in terms, I think it's still too much. So let's multiply with 0.005. So now let's just update every image to this WebGL image. So come to page JSX and let's just uh, copy this image, uh, copy this line, copy, paste. Yeah, and we have to change the source, just the source. So 2, 3, 4. If I refresh now, if I refresh now, takes a little while, but you can see this. bending effect, and it looks beautiful. Honestly, it looks really cool. So that's all for this video, and it's the base of our upcoming videos, and we are going to create some awesome effects with scroll in future videos. With that said, I'm going to see you in the next video. See you in the next one. Peace. Bye bye. Take care. Good night.